So let's begin with page 201. If you'll turn to page 201 in the book, the simplest fractional equation is like when you reduce a fraction. Like if we took 9/12 and try to reduce the fraction 9/12, how does it reduce? 3/4. Okay, can you check that? You could check this by taking the 9 times 4 equals to 3 times 12, which would be what? 36 equals 36. As a second example, suppose you took the fraction like 11 divided by 33. That reduces to 1/3. And how does that read? And how can you check that? 11 times 3 equals to 33 times 1, which would be 33 equals 33. As a third example, let's use a bigger number, like 42 divided by 96. Can you help me reduce that one? What would it be? Can you think of a number that divides into 42 and also 96? 6? 6 goes into it. 6 goes into 42, 7, and 6 goes into 96. Get your calculators out. How much is it? 16. Does it check? Oh boy. Does it check? Let's do this times this, which would be 42 times 16 equals to what? 96 times 7. And how much is that? How much is it? 672. And how much is this? 672. And it checks, doesn't it? Okay? Now, in the general form, let's use letters. Like A over B equals C over D. Can you check that for me? What would it mean? AD equals BC. Okay? Now I like that because it spells something. AD, Anno Domini, equals before Christ. Okay? And you'll see more on that later because I really do like things problems that spell something in math. So this is called the definition of equality. This is called the definition of equality of fractions. And it's sometimes called cross multiplying. All right? Now, let's get to of course, usually after you've done a few problems, if it's an algebra problem, you've got to have variables in it, don't you? So let's take a problem that has some x's in it. Like I'm on page 202. Page 202, number 6. And it's x plus 6 divided by x minus 1 equals to 1/8. All right? Did I copy it right? All right. I need your help now.
Can't you just add the 6 and 1 and that'll give you an answer with the x's?
What?
The 6 and 1, if you add them, then you'll get your 7. I'm not.
Well, what I want to do is I want to do this times this, which would be what?
Oh.
8 times x plus 6 equals to this times this, 1 times x minus 1. Okay. Now what? We're solving for x, right? So how do you solve for x? 8x plus 48 equals to x minus 1, right? And then what? Got to get the x's on one side, so what are we going to do? Subtract x. What would that give you? 7x plus 48 equals -1, and then what? Subtract the 48 from both sides. Subtract 48 from both sides, and you'll get 7x equals -49, right? And then what? Divide by 7. So divide by 7. one, the answer is x equals
-7.
-7. Final answer, right? -7. Any questions on that? Okay. On the next page, number 8. Number 8. And the problem says 3 divided by x minus 2 equals to 8 divided by 3x minus 6. Okay? There's something different about this problem. Yes?
Just a quick question. When I remember on these two, it's just when it has not a number in the top numerator, you just ignore it and use the x.
In which one?
Number 1 on that exercise, numbers 202.
Page 202. It's 4 times 2 equals to x times x minus 2. Okay? And then multiply out the parentheses and solve the resulting equation. And that turns out to be a quadratic. I introduced this definition to you of A over B equals C over D. And we call this the definition of equality of fractions. I think I forgot something really important I should have said. What is this? AD equals to BC. AD equals BC. But what I need to emphasize is that you're never allowed to divide by 0, right? In other words, in this equation, you have to be always careful that B does not equal 0 and D does not equal 0. That's an important concept in math, that we're never allowed to divide by 0. Now, I'd like to look at number 8 on page 203, and it says 3 divided by x minus 2 equals to 8 divided by 3x minus 6. Okay? Now, having said this, I want you to notice something different about this problem compared to the other one that I did a minute ago. What's different about this? You've got variables in the denominator. There's the possibility that this denominator could be 0. So before I even start this problem, is there any forbidden value that would not be allowed in this problem at all? X cannot equal 2. Can you see if x equals 2, we got a problem? So I want to sort of set an alarm that x cannot equal 2. Now let's go into this thing, and how do we get rid of the fractions in this? You can do this times this, 3 times 3x minus 6 equals to 8 times x minus 2. And now multiply out the parentheses, and let's see what you get. 9x minus 24 equals 8x minus 16. And then what?
Minus 18. You times wrong.
I times wrong.
Minus 18, yeah. Multiply wrong.
No kid.
The 24.
I was just checking to see if you were paying attention, and you did it. It's supposed to be at 18. I was just checking. And how many of you believe that on the camera? We said we need to loosen up a little bit, right? That ought to loosen me up. All right, now what? Thank you. Thanks. Let's do negative 8x to both sides. All right? Negative 8x to both sides, that would give you x minus 18 equals negative 16. And then what? Plus 18 to both sides. And what do we get? X equals 2. Do you hear sirens? Whoop, 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 whoop. Can't have x equals 2 because it makes a denominator 0. Now what happened is we weren't allowed to multiply both sides of an equation by 0. But we did it without realizing it. And now that we've done it, we realize you can't have x equals 2. It's like evidence that's illegally obtained is not allowed in the court of law, right? Now the police aren't supposed to break the law to enforce the law. I guess sometimes they do, but they're not supposed to. What does the judge say if evidence is illegally obtained? He throws it out. And what if that's the only evidence you have against somebody or that they have against you? You throw it out and and there is no case. Case dismissed. In other words, what? No solution. No solution. Any questions on that?
That's the only one.
That's the only one that could have worked, and it has to be rejected because it causes a denominator to be 0. So therefore, it's not allowed. So 2 is the only answer that could have worked, but it doesn't. That means there's no solution to this problem.
That's the only problem, that there will be no solution.
That's the only problem that there's. Right. Oh, right. Only when the denominator is 0. When the denominator is 0, you have to reject the answer because it's undefined. Division by see if you go to check this, take that 2 and plug it back in. Right? Plug it in. Plug it in. What do you get? 3 divided by 2 minus 2. 3 divided by 0. Can't allow. You can't do that. It's not allowed. Okay? All right, let's go on to number 14, which is a little more interesting. On the same page, it says 4 divided by x equals 2, x minus 2 divided by 2. And we'll do the same type of a problem. We'll do what? Start with 4 times 2 equals 2. X times x minus 2. See, I'm doing this times this equals this times this. And then what? 4 times 2 would be 8 equals x squared minus 2x. And what do we call this equation with an x squared in it? Did we do this before? Did we do this last week? What's it called? The Q equation. Quadratic equation. Right. It's a quadratic equation. Remember that? You remember it, but you just didn't remember the name. Right? And so now, how do you solve an x squared equation? What's important about solving an x squared equation? You've got to have it equal 0. So let's do a minus 8 to both sides. Right? In order to keep the x squared term positive, I want to take the 8 over to this side, make it x squared minus 2x minus 8 equals 0, right? And now what? What's the key step? Factor it? Can everybody factor that trinomial? What would it be? X. Two numbers whose product is 8 would be 4 times 2. We'll make it a minus 4 and a positive 2 equal to 0. And what's the final answer now? X equals 4 and x equals negative 2. 4 and negative 2. Okay? Any questions on that? All right. Now, turn the page. And actually, I want to turn several pages. Now that we've learned this thing, solving equations with fractions in it, you maybe have given some thought, what good is this? How will I ever use this in life? What good is this to me? So I'd like you to turn to page 216 and 218, which is a little section on ratio and proportion. In particular, go to page 218